Okay, so I hope this works okay. New year, new school. Glad to be back home. But we're going to talk about solving simple equations. So this is just review of 8th grade and just kind of teach you the process of how we're going to work things in class, okay? So these videos are supposed to be a supplement. That means if you forgot the lesson and you need to review the lesson, or you missed a day, you go back and you look at this stuff, okay? It's not meant to be, I get off scot-free in class. I don't have to listen in class because we're going to do more than just a few of these instructional videos, because this is just to start us out with and get us familiar with things. We're going to do activities that aren't going to be in these videos, or maybe in these videos, I'm not sure, depending on the rigor. But if you are going to go back over this stuff, I'm hoping that these are going to be good for review. One thing that I want to say is whenever you're reviewing or you're just taking notes over this stuff, use your headphones, other distractions away, and if you have questions, write them in the margin, and please ask them in class, because if I don't know what you're struggling with, I can't read your mind. So ask questions about steps that I've taken, okay? Check answers as you go, look for mistakes in steps, and circle problems, okay? So if your answers are wrong, it's either the solution in the packet is wrong or your steps that you took were wrong, okay? So it's important early on to look for mistakes, and we will practice this in class. Whenever we are doing board problems, I'll give you guys whiteboards to work on, and what you'll find out is some of you guys are going to start arguing with each other to see whose steps are correct. And if you're incorrect, don't fret. It's just an opportunity to learn, okay? If a problem is confusing, circle it. Don't give up on it, okay? Application. Applying what you've learned, think differently, have grit. So apply what you've learned. Don't just throw it out whenever you're done with it. Think outside the box. Use critical thinking. That's one of the reasons why they make you do math, right? You're not going to have to solve a bunch of equations whenever you go into a job, unless you're doing my job or unless you're a physicist or a chemist, which all of you, I think, have the ability to do so, but it's whatever you want to do with your life. But you will have to think critically. Given information, you will have to think critically and solve problems, and then have grit. And that just means don't just... Having grit means taking what you've learned and standing firm. Don't give up. Because some of these problems, I understand they're going to be tough, but that doesn't mean that it's okay to just give up, okay? Standing firm and persevering is super important, okay? So we're going to talk about inverse operations. So basically the idea is whenever you're solving an equation, step by step you want to do the opposite to solve for the unknown value. So if you see an addition operation, you want to do subtraction. If you see a subtraction operation and you want to move something to the other side of the equality sign, you do addition. Multiplication and division are inverses, so if you see multiplication, to undo multiplication you can divide, to undo division you can multiply, okay? So this is going to be super important. So here's the first equation, and actually you don't have to do it in this order. It's whatever preference you want. So I'm going to show you two ways to do this problem. They're saying to multiply by 2 on both sides of the equation. Okay? And whenever you have a quantity like a plus in front between two quantities, between two items, you have to distribute. So if I'm going to do it their way, I'm going to show you how to do this. If I want to do it their way, what I'll have is, make sure I've got a nice color here. I'm going to do black. So if I have, right, x is being divided by 2 here. If I multiply by 2 on both sides of this equation, what I've got is 2 times x over 2 plus 3 equals 2 times 19. Okay? So 2 times 19 is going to be 38. And then 2 distributes here. Okay? So 2 times x over 2, I can think of x over 2 as 1/2 times x. Okay? So 1/2 times x plus 3 times 2 is going to be 6. Oh no, I'm not there yet, sorry. That's not correct. We haven't distributed yet. So I can think of x over 2 as 1/2 times x plus 3. And whenever we multiply, right, we distribute to both terms. So I'm going to go ahead and distribute now. So I've got 2 times 1/2 x plus 2 times 3, which is 6, equals 38. Okay? So 2 times 1/2, that's just going to be 1. You're basically taking 2 and dividing it by 2. So I'm going to go ahead and erase this and put 1 here. So this is 1x plus 6. Clean that up a little bit. And what I want to do is solve for x now. So as long as x, the number in front of x is 1, you've isolated it, you've gotten it alone, okay? So what I want to do is, instead of adding 6, I'm going to subtract 6 from both sides. And what I've got is x equals 32, okay? So that's one way to solve the problem. So hopefully you were following along with that. I didn't mean to confuse you with all the terminology, but here we go again. I'm going to erase all this. So if you need to go back, you can pause the video. You can rewind the video. And this is my preferred method. I tend to get rid of the constants. Hello. I guess that power went out. Oh, it's motion. I tend to get rid of the constants that are with this variable. So I've got a plus 3 here, right? So what I'm going to do first, instead of addition, I'm going to do the opposite to solve for this x. And that's the goal, is to solve for the unknown variable, okay? So when I subtract 3 from both sides, what I'm going to get is 16 on the right-hand side, and I get x over 2 on the left-hand side. So whenever you divide, right, x divided by 2, what is the opposite of division? Well, the opposite of division is going to be multiplication. So you're going to multiply both sides by 2. So 16 times 2 is 38. And then 2 divided by 2 is 1. So I've got x equals, no, it's not 38, that's 32, my bad. 32, x equals 32. And that's the way the cookie crumbles there. Okay? So let's do a few example problems. F plus 2.5 divided by 3. Okay? So what I'm going to do is, since f plus 2.5 is in the numerator, they're both in the numerator, and they're both being divided by 3. So what I want to do is I want to get rid of this division of 3. So what is the opposite of division? Well, the opposite of division is multiplication. So I'm going to do 3 times the left-hand side, and then 3 times the right-hand side. So 3 divided by 3 is 1. And then I get 6 on the right-hand side. So I've got f plus 2.5 equals 6. And then I've got an addition here, okay? So what I do is I subtract 2.5 from both sides. And then 6 minus 2.5 is 3.5. So f equals 3.5. Let's do another example. Okay. So what I want to do here is I want to isolate r. I want to get r alone. And the only way to do that is to have the coefficient in front of r be 1 and no other terms with r. So on the left-hand side, I've got this negative 12 here, and I want to get rid of that. So what I'm going to do is I'm going to add 12 to both sides. So negative 4 plus 12 is going to be 8. Okay? So what I've got is 16r equals 8. And then what I want to do is I want to get rid of this coefficient, right? So whenever you see a number with a variable, the operation that's between the two is multiplication, okay? So this is 16 times r. So what I want to do is I want to get rid of 16. So what is the opposite of multiplication? Well, that's going to be division. So I'm going to divide both sides by 16. And when I do that, I get r equals 1/2. So 8 divided by 16 reduces to 1/2. So I hope you saw that, right? Whenever you have fractions, you want to get them to be what's called coprime. And the only way to get something to be coprime is to divide the top and bottom of the fraction by a common number. So 8 divided by 8 is 1. 16 divided by 8 is 2. So r equals 1/2. So that's that one. So let's look at a few more. Whenever you have addition or subtraction, and you've got more than one variable that are the same. So I've got 2j minus 4j. They work just like numbers, okay? Except you keep the variable. So 2j minus 4j is going to be negative 2j plus 10 equals 12. So what I did there was combined like terms. It's called combining like terms or collecting like terms. Let me write this out step by step. Collected like terms. And then the next thing I want to do is I've got addition. So I want to subtract 10 from both sides of the equation. So all that means, subtraction, property of equality, all it means is if I subtract the same amount from one side of the equation and the other side of the equation, that just means that the two sides are balanced. I've done a legal move. This is fine to do. So if I subtract 10 from both sides, then I'm okay to subtract 10 from the other side. So I get negative 2j equals 2. 12 minus 10 is 2. So now what I want to do is get rid of this negative 2 as a coefficient. So what is negative 2 doing with j? Okay, what is the operation between these two? Well, the operation is multiplication. So to undo multiplication, I'm going to divide both sides by negative 2. And 2 divided by negative 2, 2 divided by 2 is 1, so 2 divided by negative 2 is going to be negative 1. So j equals negative 1. Okay, let's do another one. So right here I've got 1/3 x plus 10. What I like to do is I like to flip the two equality signs so I can keep the x on the left-hand side. It's just a personal preference of mine. So if I have 5 equals 1/3 x minus 10, I also have that 1/3 x minus 10 equals 5. Okay? So what I want to do is get rid of this subtraction. So in order to get rid of a subtraction, I'm going to add 10 to both sides. And I get 1/3 x equals 15. And then I've got 1/3, right, which is the same as dividing x by 3, right? What I want to do is I want to multiply by the reciprocal on both sides. So what is the reciprocal? Well, the reciprocal is the swapping. I need to write that O. Of numerator and denominator. So multiplying by the reciprocal is taking that fraction, reciprocating it, and then multiplying by it, okay? So if I swap 1 and 3, I'm going to have 3 over 1. And I multiply that by both sides, okay? Well, if I look over here, 3 divided by 3 is 1. 1 divided by 1 is 1. So I'm left with 1x equals 15 times 3 over 1, which is 15 times 3, which is just 45. Okay? So we got 2 more here, and I might do a few more just to make sure that I really got that process down. I've got d, negative d over 5. So what this is essentially doing is what I have is negative 1/5 times d equals 12. So I just flip those two. And whenever you have a negative coefficient on d, you want it to be positive, okay? So the first step that we can do is we can change the sign on both sides. So if I want to get rid of this negative, I'm going to multiply both sides by negative 1. Now hear me out here. A negative times a negative is a positive. A negative plus a negative is not positive, okay? Negative times a negative is a positive, so I'm left with 1/5 d equals negative 12, okay? So 1/5, I want to multiply by the reciprocal. Or I can think of this as d divided by 5. Well, what's the opposite of division? Well, that's going to be multiplication. So I'm going to multiply by the reciprocal. So I'm going to multiply by 5 over 1 and 5 over 1. Well, the 5s will cancel, and I'm left with 1. 1 divided by 1 is 1. 5 divided by 5 is 1. So I've got d equals negative 60. And then over here. So on this one, what we actually have to do is we have to combine like terms. Whenever you have a fraction involved, it can get a little dicey. Okay. What you have to do is convert your constants to fractions. So first, we're going to do the opposite of what we see. So I've got negative x over 3 plus 3. So even though this is a subtraction sign, it's modifying the thing immediately to the right. So 3 is actually positive here. So if I write this on the other side, I can write it like this. And it's equal to 1/5. So what I want to do is subtract 3 from both sides of this equation. And I get negative x over 3 is equal to negative 3 over 1 plus 1/5. Now I can't combine these two like terms yet because they don't have a common denominator. So whenever you add fractions, you have to have the same number in the bottom of the fraction. So that's called a common denominator. So there's one way that we can get a common denominator, one easy way, and that's to multiply upstairs and downstairs by the other denominator. So I want this denominator to be 5. It's right now it's 1. So what I want to do is I want to multiply upstairs and downstairs of this denominator by 5, okay? So negative 3 times 5 is negative 15 over 5 plus 1 over 5. And I've still got that negative x over 3. So if you haven't touched something, and this is kind of important, if you haven't touched something, you just bring it down, okay? Whatever you have on both sides of the equation, you just bring them down constantly. So I've got negative x over 3 equals negative 15 over 5 plus 1 over 5. And what this allows me to do is it allows me to add across the top and keep the denominator. So negative 15 plus 1 is going to be negative 14. So in the next line, I've got negative x over 3, that hasn't moved, I haven't done anything with that, is equal to negative 14 over 5. Okay? And you can check this with the calculator. Negative 15 over 5 plus 1/5 is equal to negative 14 over 5. Now what I want to do is I want to get rid of this negative 3, but it's being divided, okay? So what is the opposite of division? Well, that's going to be multiplication. So I'm going to multiply both sides by 3, but it's also going to be a negative 3. So that negative, a negative times a negative is a positive, so those will change to positive. And then negative times a negative over here is also going to be positive, so that will be positive. So positive 14 times positive 3, it's not a 13. Looks bad. Positive 3, 14 times 3, 28 plus 14, 38, 42. Yeah, 42 over 5. Is equal to x. And we're done. You can leave it like that, and that is a valid answer. And it says you try it. I'm going to do these two with you. So what I encourage you to do is pause the video, try it out for yourself, and then we'll go over it. Okay? So I've got 8 in the denominator over here under x minus 4. So I want to get rid of that first, right? Everything on the right-hand side is being divided by 8. So if I multiply both sides by 8, I get 8 times a half, or 8 divided by 2. Well, 8 divided by 2 is going to be 4. And then 8 divided by 8 is going to be 1. So I'm left with x minus 4, so that stuff, equals 8 divided by 2, which is 4. So all I have to do now is get rid of this constant term that's with x. I want to get x alone, so I've got negative 4. So subtraction of 4, the opposite is addition. So I'm going to add both sides, and hopefully you got x equals 8. And what you can do is you can go back and you can check and make sure that the original equation works. So I'm going to show you how to do that. So if I go back to 1/2 equals x minus 4 over 8, plugging in 8 in for x should work. So I've got 1/2 equals 8 minus 4 over 8. Well, 8 minus 4 is 4, so 4 over 8 equals 1/2. If I reduce 4 over 8, 1/2 does equal 1/2. So the value of x is supposed to make the equation true. Here's another one. 1 minus 4y minus 9y equals 14. Well, negative 4 plus negative 9, that's going to be negative 13y. And then this 1 is positive, right? There's no negative in front of it, so it's going to be negative 13y plus 1 equals 14. So I've got plus 1 equals 14, so the opposite of addition is subtraction. So I'm going to subtract both sides by 1. So I've got 14 minus 1 is 13, and I've got negative 13 y equals 13. So I'm going to divide both sides by negative 13. 13 divided by negative 13 is negative 1. And y equals negative 1. Okay? So I am going to do one more, but here's my encouragement. If this is still confusing, do not wait to move on to the next few lessons because it only gets tougher from here, okay? So if you are confused, come in and ask questions. Come in the morning, come in the afternoon, ask questions during class. My goal is to get you to master it. So if you are confused and you are having trouble, we need to talk, okay? So we're going to do one more. So my encouragement is for you to try this on your own, pause the video, and if you still cannot get it, then we need to talk, okay? So I've got 2x minus 10, and what I want to do is I want to get rid of this subtraction of 10. So the opposite of subtraction is addition. So I'm going to add 10 to both sides. So I get 25 equals 2x. Well, what's happening between 2 and x? Well, that's multiplication. So what's the opposite of multiplication? Well, that's going to be division. So x equals 25 over 2. And we're done. That's it. That's all you got to do. And I hope that helps.